All right, let's do an example. We'll do two of them, one on this video, one on the next. So find the center and vertices and graph the ellipse described by, right? X minus 1, the quantity squared over 9, plus the quantity y plus 3, that quantity squared over 4 equals 1. Now, if it didn't say ellipse, how do we know it's an ellipse? Well, first of all, you have an x term that's being squared and a y term that's being squared. Actually, a y plus 3 squared term, but and they're both positive. Okay, and the numbers underneath are different, so I know that it's not a circle. Circle is an ellipse, but usually they would just say circle if it was a circle. So that's how you can tell it's going to be an ellipse. It's stretched more in the x direction than in the y direction because the 9's bigger than the 4, right? So it's going to be a horizontally oriented one. The center I can tell right away is 1 minus 3. How do I figure that out? Well, it's the same thing. It's the same old, right? You set this equal to 0 and solve for x. You get x is 1. So that means you go 1 in the x direction. I'm sorry, I'm sorry, messed that up. Let's not worry about shifting here. This means that you get x equals 1. It means the x coordinate of the center is 1. It works like with the parabola, it was the vertex. Here it's the center, right? And here we do the same thing with y. So y plus 3 equals 0, y equals negative 3, negative 3. It's that simple. If you think of it that way, you won't get these signs wrong. Okay, so the center, what else did they ask for? The vertices. So there's two vertices, and we have to know what A and B are. So I'll write down what A and B are. I would always write those down. It just makes it easier. And the bigger one, for ellipses, the bigger one is always the direction you go for the vertices. So you can see the bigger one is 3, clearly. So I would go that's under the x, right, the 3 squared. So I would go in the x direction. So I'm adding and subtracting 3 from the x coordinate, the first coordinate. So you take, for one of the vertices, you'll have 4 minus 3, you add 3. And the other one you subtract 3, you have minus 2 minus 3. So I'll go ahead and do that. Right? And then actually write out what they are. Yeah. So that's not too bad, right? You just have to know which way you're going, and then always use the larger of A and B. And write down both A equals 3 and B equals 2. Don't just write down 3, 2 or something crazy. Right? Write it like I'm writing it pretty much. Okay. So that's the center. I graphed 1 minus 3, or 1 negative 3, I'm sorry. 1 negative 3. 1 minus 3 would be 2, or negative 2. 1 comma negative 3. And then there's the vertices. What did I do? I just went over 3. Now, if you get confused with this subtraction here, just graph it. And then it says, oh, go in the x direction by 3. So just go over 1, 2, 3. There it is. And then write down what the coordinates are. 1, 2, 3. It's pretty easy if you have integers, and most of these are designed to give you integers. It's conceivable you could have like a square root of 3 or something, but I think they have them all planned out where you get integers. So you just freaking count, you know. It's just to get used to it. Try to do this and then count it to actually see if it makes sense. Okay, the center should be the midpoint halfway between the two. Okay, what are those 2 points? That's from B, right? B is 2. That's in the y direction. This is b squared, right? It's in the y. So from the center, I go 2 and 2 in the y direction, up and down. And then you could just sketch in an ellipse. I used an ellipse tool, so it's actually perfect. But on Hawks, they would probably just have you graph these points, like maybe the center and these two or something, and then it would just fill it in. Or they might not have you physically graph it. They might give you multiple choice, but then also ask you for what the vertices are and what the center is. Actually, I think they usually have the center at the origin, so that's not very challenging. But they'll ask you where these vertices are. Yeah, I'm just trying to think of what else they could ask you for. I think that's about it, yeah.